The exposed earth of a crawl space provides a major entry point for radon and other soil gases into a home and is an area that should be treated in any radon control project. This is typically done by using a technique referred to as submembrane depressurization, where a durable polyethylene sheet is laid on the soil and sealed the foundation walls, columns, and its seams. Radon is then collected from beneath the plastic sheet with the use of a radon fan and exhausted to a proper location above the eave of the home. Before initiating this work, one should inspect the crawl space for hazards such as friable asbestos, spiders, snakes, and potential hantavirus concerns. If these are encountered, special precautions are warranted, and in many cases a professional should be used to implement the repairs. If there are stored materials, excess debris, or sharp objects that may damage the plastic sheeting, these should be removed first. Next, a length or loop of perforated pipe should be laid on the earth with the T-fitting connected to it and positioned in a location appropriate for your planned vent system routing. Cut the polyethylene sheeting in a convenient location outdoors to the rough dimensions of the crawl space with additional material to allow for overlapping seams and adhering the plastic at least 12 inches up onto the walls. It is also a good idea to lay carpet scraps on the soil in areas of potential traffic to protect the poly when accessing appliances such as water heaters. Spread a section of plastic out on the crawl space floor beginning with the walls. Apply a thick and continuous bead of polyurethane caulk approximately 8 to 10 inches up on the wall. Press the plastic into the caulk line, which will form an edge seal. Cut your plastic sheeting or use scraps of plastic to seal the barrier to pads and support posts. If there are appliances such as furnaces in the crawl space, you can seal the plastic to the pad beneath it, or if there is no pad, you can temporarily suspend the appliance with metal strapping, remove the blocks, slide the poly beneath the appliance, and then replace the support blocks. Be sure to also seal around pipes that come up from the soil, such as water or sewer lines, being sure to allow for access to any cleanouts. After all penetration seals are made, overlap seams and seal them by applying a continuous bead of caulk and overlapping the seam edges. To complete the foundation portion of this system, connect your solid PVC Schedule 40 piping to the riser and route it to your planned vent system. After the system is complete and the fan is turned on, you will see the plastic drawn down towards the soil, which is evidence of how well the system is working. If you hear leaks or identify them with a smoke bottle, apply additional caulk to seal them. Water drainage systems, especially if they are connected to a sump inside the home, can provide an easy pathway for radon to enter the home. However, if you put a sealed lid on the sump and connect your radon venting system to it, you can very effectively reduce radon in your home. Connecting a radon system to a sump is very easy. There are several commercially available lids that will bolt and seal to the floor, and they also have penetrations for the plumbing from your sump pump as well as for the radon vent pipe. You could also make your own sump lid out of clear plastic such as Lexan, so you can easily look into the sump. If you make your own, you will need to acquire rubber grommets to seal around the pipe penetrations. Regardless of what sump cover you use, it is important to be sure that it seals well to the floor and that you do not do anything that would impede the system from collecting and pumping water away from your foundation. After your sump cover is in place, you can easily connect your radon vent pipe to it and route it to your planned fan location. If you do not have an interior sump, but rather have an exterior drain located along the footing of your foundation, you can also connect a radon system to it. To connect to an exterior drain, you will have to dig down to the drain, which will typically be near the footing, which will be below frost line. If this is more than 3 feet, you should shore up the hole to prevent it from collapsing in on you. Remove any decorative material or rocks so you can replace it after you are done. It is highly recommended to hand dig down to the drain, carefully avoiding sprinkler and other utility lines. Once you get near the drain, which is located at or below the footing, you will encounter a geotech cloth. Carefully cut and fold this back so it can be replaced later. Once the drain is exposed, connect your 4-inch Schedule 40 PVC or ABS radon vent pipe to the drain. Then lay the geotech cloth back over your connection. Replace the excavated dirt, compacting it as you go, at least once every 6 inches. If your perimeter drain is designed to drain water away from your home by gravity to a spot on a hillside, you will need to locate the ends of these pipes, and there may be 2 of them. Once located, install a check valve on the end that will allow water to drain away but not suck air from the outside. After you have put check valves on the soakaways and installed the vent riser to your drain, you can connect your radon fan to it. Do not bury the fan, but rather have it located a couple of feet above grade level. Radon and other soil gases can also be removed from beneath the slab foundation when a vacuum is applied to a suction pit created beneath the slab. This technique is known as sub-slab depressurization. The suction pit is typically installed at a location on the slab that is near an outside wall to take advantage of soil settling that typically occurs near footings. It is also a location that typically does not interfere with interior space. In fact, a location in the center of the slab is often the least effective location. For most homes, only one suction point is necessary. However, in some homes where there are obstructions to lateral subslab airflow, like intermediate footings for load-bearing walls, or when home additions are separated by foundations, it may be necessary to have more than one suction point, which will be located on opposite sides of the obstruction, all of which can typically be connected to the same radon fan. Multiple suction points may also be needed if there are more than one slab level. Again, if routing allows, these can be tied together and connected to a single fan. The creation of the suction pit is very straightforward, with the floor-to-pipe connection often being accomplished with a 6x4-inch PVC reducing bushing that fits into a 6-inch slab hole and reduces down to 4-inch to accommodate the vent system. To install the fitting, draw an outline on the floor at a point to avoid contacting a spread footing under the slab. Drill the slab along the outline using a hammer drill. A core rig can also be used if you are comfortable with this type of machinery. After your holes are drilled, chisel out the plug and clean up the edges so your reducing bushing will fit into the hole. It is very important that you dig out a pit beneath your hole, removing at least 10 gallons of soil. Also, the tighter the soil is, the more dirt you should dig out. Install the bushing by applying caulk to it and twist it into the hole. Apply additional caulk between the edge of the fitting and the floor to assure a good seal. After the suction point is complete, simply glue your vent riser to it and route it to your fan. The radon vent system is common to all active soil depressurization approaches and consists of a specially designed fan that runs continuously. When it is connected to the subgrade via a simple system of PVC or ABS pipe, radon-laden soil gas will be drawn from the soil and exhausted to a safe location above the home. The system can either be routed through the interior of the home or up alongside of the home, provided the discharge is above the eave of the house and well away from building openings such that the discharge gases will not re-enter the structure. There should be positive drainage back to the subgrade so condensed moisture does not accumulate and disable the system. The fan and any portions of the discharge piping should not be routed through conditioned space of the home or under occupied space. Consequently, fans can be located in the attic, garage, or outdoors. They should not be located inside the home, in a crawl space, or in garages with living spaces above them. The fan should be connected to the radon vent pipe with flexible connectors both above and below the fan. It is also very important that the fan be installed vertically to prevent accumulation of water in the housing. As far as the piping, it can be either Schedule 40 PVC or ABS plastic. Sheet metal or flex duct should not be used. All fittings should be primed and glued and the pipe well supported. For aesthetic purposes, commercial-grade downspout can also be used for portions of the system that are outdoors, but do not use downspout indoors. Regardless of the type of piping used, the discharge should be routed up to a point above the eave and at least 10 feet away from any building opening that is less than 2 feet below the discharge. It is also recommended that a screen with openings no smaller than a ½ inch be used to prevent birds and squirrels from entering down the discharge. Also, if you decide to route the pipe up through the interior of the home, you will need to flash around the pipe to avoid roof leakage. Also, if you run the pipe through a firewall or fire ceiling, it is important that a fire collar be placed around the pipe to maintain the fire rating of the wall. Although you will test your home to verify the success of your system, you should also install a performance indicator that can tell you in the future if the system should fail. This could be a simple manometer that measures maintained vacuum in the system, or if you use a low-voltage fan system, it will be a meter that easily indicates if the system should fail, which is very rare. As a finishing touch, you should also label the system at all points it can be seen. This helps future owners of your home understand they have a valuable system operating in their home. Active soil depressurization systems operate by creating a vacuum under the foundation. However, they can also pull air from inside the house via leaks in the foundation, such as slab joints and plumbing penetrations. Whenever practical, one should seal these openings with polyurethane caulk to make the system work better and to reduce the loss of conditioned interior air. To seal a slab's wall joint, vacuum up loose debris and apply a thick bead of caulk. Using a piece of cardboard, smooth the caulk into the joint so it goes up on the wall and onto the floor by at least 3/8 of an inch. If the slab is poured tightly to the wall, as in a cold joint, you should also caulk these joints if they are accessible. If you have control joints that are exposed, and especially if they are cracked, it would be a good idea to caulk these as well. Another major leak point can be plumbing penetrations. To seal these, cut back any expansive material and apply caulk completely around the base of the penetration and tool the caulk into the joint. Other places to seal can be blockouts for tubs and showers, as well as installing a gasketed and bolted lid on an interior sump, regardless if you are applying your system vacuum to it or not. It is typically not necessary to remove wall treatments to caulk joints, but rather caulk those you can access, but you should always conduct a backdraft test on combustion appliance vents to assure they are working properly.